Hi, Algebra 1, 2-8, Proportions and Similar Figures. The essential understanding is that you can use proportions to find missing measurements that you might want to find. Let's talk about some vocabulary. Similar figures are figures that have the same shape, but they might be different sizes. One might be bigger or smaller than the other one. A scale drawing is a drawing that is similar to an object or a place. Scale drawing examples are like a map, or a floor plan of a house or something, or a blueprint. Scale model, scale, let's go back to that one. What is a scale? That's the ratio used to find the actual length of something. A scale model is a three-dimensional model similar to the real thing. The symbol, this little wavy line, means that is similar to, just like the double bar means equal to, or a sideways V means is less than or might be is greater than. This little wavy line means is similar to. Let's talk about three examples. First one is, what if I've got a sailboat and I'm making a model, and the sailboat's sail is actually 12 feet tall and the sailboat is 9 feet in length, so I have my model with the sail's 4 feet tall, and I wonder how long I need to make the base of the model boat. Let's take these lines out for just a minute. If you notice, sometimes when I've got a word problem, if I line up my information, I already set things up to make my algebraic statement. Like, if I draw a line between the 12 and the 9, put an equal sign in here, and draw a line between the 4 foot and the base, I've already set up a proportion. 12 foot tall on the real boat to a 9 foot base equals 4 foot tall on the model to the we don't know what base. The important thing in setting up a proportion is that you are consistent. I put the information for the real boat over here, information for the model boat over here, 12 foot tall to 9 foot base, 4 foot tall to we don't know base. If I had switched this information, and instead of putting this, if I had put the base first and the tallness underneath, I would have gotten the wrong answer. Just so you know that it has to be consistent. Let me erase this. So we'll go back to the way it's supposed to be. And I'll take these lines, because the way we solve it is to cross multiply. So we're going to cross multiply 9 times 4 and get 36. 12 times my variable. So I divide by 12 in order to both sides in order to get my answer, that is my variable, is 3 feet. So in order to make this similar, I need a 3 foot base. Let's do another model, or another example. Suppose I just want to find the length of a side of a triangle. And I have the information that triangle ABC, the big one, is similar to triangle DEF, the little one. I can easily set up a proportion because I already have my information laid out. I could draw a line between here is equal to, and a line between here, or should I put it over here? Where should I be putting this line? Well, let's see. What do I want to find out? I want to find out the length of DE. DE is right here. So my line, just like here, 10 foot for the short side, 16 for the long. We don't know the short side, 12 foot for the long. Well, what's this 18? Guess what? It's just extraneous information that we don't really even need. So I use the 10 foot to 16 foot equals my x to 12 foot. And actually I wanted to use that x. So now I've set up my proportion. How do I solve that? Cross multiply. 10 times 12, 120, equals 16 times x. Remember, I told you the shortcut is divide by the number that connects to the variable. Divide by 16 is going to equal that side. If I did the math of 120 divided by 16, I would find out that that came to 7.5, or 7.5 equals the measurement of the x side. So x is 7.5. Let's check if that makes sense. 10 is a little bit shorter than 16, but bigger than half. 7.5 is shorter than 12, but more than half. At least my answer makes sense. Let's do one last example. You can use similar figures and proportions to find lengths you cannot measure directly. What do I mean by that? Suppose I wanted to know how tall this building was. And unless I was Spider-Man, I might have a hard time climbing up that building to measure the height of it. So here's a cool thing that can help me out. The sun's rays strike the building and the grill at the same angle, forming two similar triangles below. So now how do I find out how tall the building is? Well, here's the building's shadow. Here's the grill's shadow. Height of the grill to shadow. Height of the building to shadow. Make similar pieces of a triangle. Just like when I was solving for the either triangle or the boat, if I draw a line through my information, I've already set up proportions. So I can go 5 feet to the girl's height, 5 feet of the girl's height to 3 feet of her shadow equals, I don't know how tall the building is, to its 15-foot shadow. I can do the multiplication. 15 times 5 is 75, divided by my 3 equals how tall the building is, so my building is 25 feet. What if I decided that I would do height of the girl to height of the shadow? Can I do that? Height of the girl, to height of the building equals shadow of the girl to shadow of the building. Can I do that? Girl information, building information, height, shadow, shadow. Yes, look, my math is the same. 15 times 5 divided by 3. This one's real important for an activity that I want to do in class. See you in class.